Hello, and welcome to the FireVoxel tutorials. In this tutorial, we will introduce FireVoxel's basic image transformation tools and show how to use these tools for image rotation, translation, and change of resolution. Superimposing medical images acquired with different parameters or different imaging modalities requires changing image orientation, position, and resolution. Here, we will introduce the tools in the FireVoxel's Transform menu for performing these actions. The transform operations change the image data and allow saving the transformed images, unlike the view operations, which only change the way the images are displayed. We will begin by reviewing the rotation and translation operations performed with the help of vector objects. Let's open two MR images of the brain: a T1 weighted MP-RAGE image and an arterial spin labeling or ASL image. These two-dimensional images have the same matrix and resolution, and therefore we can display them in the same document window. Our goal will be to superimpose the brain in these images. We will shift and rotate the ASL image to align it with the T1 weighted image. The shift or translation is done with the help of a vector line. Let's adjust the transparency of the top ASL layer and find matching landmarks on the medial axis of the brain on each image. We can determine the coordinates of the landmarks by drawing vector regions of interest with their handle corners positioned over the corresponding landmarks. We will place the lower left corners of the ROIs on the landmarks. Note that using the vector ROIs is helpful but not required. To draw a vector, use Construct Vector Polyline on the main toolbar and draw a vector connecting the landmarks. Once the first point is placed, the direction and length of the vector will be shown. After placing the second point, press Escape to finish. Now, turn off the visibility of the T1 weighted image. The translation operation acts on all visible layers, so the T1 weighted image should be invisible, otherwise it will also be moved. With the vector active, use the main menu to select Transform, Translate using Vector. The ASL image will be shifted as indicated by the vector, and the vector line will be deleted. We can save this new alignment as a FireVoxel document. To undo this transformation, select Transform, Discard Alignment. To recover it, close and reopen the just saved document. Next, we will need to rotate the ASL image using a sector. But first, let's draw two vectors to help us determine how much we need to turn it. Keep the vector ROI positioned over the common landmark and delete the other one. Draw a vector line along the medial axis of the brain on the ASL image. Now, make the ASL image invisible and draw another vector along the medial axis on the T1 weighted image. Right-click and drag these vectors so that they intersect at the common landmark, which will be the center of rotation. The angle between the two guiding vectors shows how much we need to rotate the ASL image counterclockwise. Again, these guidelines are helpful, but not required for the next step. To rotate the ASL image, we will use a sector, a vector object made up of 3 ordered points. Again, use the Construct Vector Polyline tool. Place the first point along the ASL axis, which is the starting direction. The second point at the center of rotation, and the third point along the T1 weighted axis, which is the final direction. Then press Escape to finish. To adjust the sector, click on it and drag each control point individually. To move the sector, right-click on it and drag it to a new location. The angle of rotation is shown next to the sector and is about 19 degrees. The direction of rotation is important and indicated by an arrow. Turn off the visibility of the T1 weighted image. Activate the ASL image and make sure that the sector is also activated. Use the main menu to select Transform, Rotate using Sector. The ASL image will be rotated, and the sector will be automatically deleted. Next, we will save the information describing the sequence of transformations we just performed as the volume transform file. This file can be used to repeat these transformations or apply them to other images with the same dimensions. Make sure that the transformed layer is activated and select Transform, Save Alignment. You will be prompted to save the .vtf file for your transformation. Now, let's open this file in a text editor. The .vtf file shows the transform type, in this case, affine. It also contains the matrix dimensions and resolution of the original and transformed images. These are followed by the transform data. These 12 numbers are the elements of the affine transformation matrix. In the .vtf file, these elements are listed row by row. Several FireVoxels transformation and co-registration operations use and create the volume transform files. Let's reopen the original ASL image. Now use Transform. Transform using VTF, and select the .vtf file that we have just saved. The image will be shifted and rotated as we have just done manually. The Transform menu offers additional commands for image rotation and resampling. We will demonstrate these operations using a CT image of the right leg. Let's display this image in 3 orthogonal planes. This image shows a fracture of the fibula. However, the leg bones are not aligned with the image planes, and the fracture is difficult to see. We can rotate this image in 3 dimensions for a better alignment. We can again draw sectors in XY, XZ, and YZ planes to estimate the angles of rotation. We have previously determined that we need to rotate this image by -10 degrees about the x-axis, 5 degrees about the y-axis, and 40 degrees about the z-axis. Now select Transform, Rotate, and create new volume. This will open a panel with the options to configure this command. Enter the 3 angles of rotation about the X, Y, and Z axes. To keep the original image dimensions, check the box marked Preserve Original Field of View and Resolution, and click OK. The transformed image will be opened in a new document window. We can view it in 3 orthogonal projections for comparison with the original. Now, the bones are better aligned with the imaging planes, and we can see the fracture more clearly. The Rotate command can also be used to change the image resolution and create a new image with isotropic voxels. Our original image has the in-plane voxel dimension of 0.47 millimeters and slice thickness of 2.5 millimeters. Let's start with the original image and run the rotate command again. The change of resolution is performed using the scale coefficient and interpolation options. The scale is equal to the ratio of the smallest dimension of the original voxel to the target voxel dimension. By default, the scale is equal to 1. If the scale is 1 or greater, the transformed image will have smaller voxels than the original. We will call this operation upsampling. To change the resolution, uncheck Preserve Original Field of View and Resolution. For CT images, let's keep Trilinear Interpolation. For MRI, sync interpolation methods are more suitable. Click OK. This operation creates a new volume and displays it in a new window. The transformed image has 0.47 mm isotropic voxels and a large matrix and field of view. Resampling an image to isotropic voxels can also be performed by using Make Isotropic. By default, the target voxel dimension is set to the smallest dimension of the original voxel. This operation creates an image with isotropic voxels and the same orientation and field of view as the original. To resample the image to a lower in-plane resolution, which we call downsampling, we will use the scale coefficient less than 1. Let's start with the original image and run the Rotate and Create New Volume command again. We will resample this image to isotropic 1.2 mm voxels. This requires the scale coefficient of 0.389. When the image is downsampled, we can select a downscale method. Select Gaussian Downscale and click OK. The resampled image will have 1.2 mm isotropic voxels. Now, select the original image and run the Rotate command again, but this time with regular downscale. When Make Isotropic is used to resample an image to larger voxels, it uses regular downscale. To illustrate the differences between the downscale methods, let's open a two-dimensional binary image. Let's display it on a 10 mm grid and resample it to 10 mm voxels using the Rotate command. First, select the regular downscale. Next, select Gaussian downscale with a 10% threshold. Repeat it with a 20% threshold. And finally, use a 50% threshold. Regular downscale determines the new voxel values based on a simple average of the original voxels and a 50% threshold. Gaussian downscale first applies a Gaussian filter and then determines the new voxel values based on a user-specified cutoff. As a result, Gaussian downscale may be able to preserve the image details that would be lost with regular downscale. This concludes this tutorial on FireVoxel's tools for basic image transformations. These operations may be used for manual image alignment, and their elements are also involved in more complex co-registration tools available in the Register menu. For more information, please visit our website. Thank you.